Why do stars twinkle? This question has fascinated stargazers for centuries and provides a perfect opportunity to dive into some of the fundamental principles of astronomy and atmospheric science. For students studying astronomy, understanding why stars appear to twinkle can reveal insights about light, the Earth's atmosphere, and the vast distances that separate us from these celestial objects. Let's break it down and explore the science behind the enchanting twinkle of stars. When we look at stars from Earth, we're observing their light after it has traveled immense distances, sometimes hundreds or thousands of light years, to reach us. A star itself doesn't twinkle, it emits a steady stream of light, radiating uniformly in all directions. The twinkling, or scintillation, happens because of the way this light interacts with Earth's atmosphere before reaching our eyes. To understand this, we need to examine how light behaves when it passes through different layers of air. Earth's atmosphere is made up of layers of air with varying temperatures, densities, and compositions. These differences create pockets of air with different refractive indices, meaning they bend or scatter light in unique ways. When starlight enters the atmosphere, it passes through these turbulent layers, causing the light to change direction slightly and repeatedly. This constant bending of light is known as atmospheric refraction, and it's why stars appear to twinkle when seen from the ground. The effect is more pronounced for stars near the horizon. When you look toward the horizon, starlight passes through a thicker layer of atmosphere compared to when you look directly overhead. This means the light encounters more turbulence and varying air densities, intensifying the twinkling effect. On the other hand, stars closer to the zenith, the point directly above you, appear steadier because their light has less atmosphere to travel through. Planets, however, don't twinkle as noticeably as stars. This difference is due to the apparent size of these celestial objects in the sky. Stars, despite their immense size, appear as tiny points of light because they are so far away. This means their light is easily disturbed by atmospheric turbulence. Planets, on the other hand, are much closer to us and appear as small disks rather than single points. The light from a planet averages out across its disk, making it less susceptible to the effects of atmospheric refraction. This is why planets like Venus, Jupiter, and Mars often shine steadily, while stars seem to dance and flicker. The twinkling of stars is not just an interesting phenomenon. It also has practical implications for astronomers. Atmospheric turbulence can distort the images of celestial objects, making ground-based observations less precise. To combat this, astronomers use techniques like adaptive optics, which involve rapidly adjusting telescope mirrors to compensate for atmospheric distortions in real time. Alternatively, they place telescopes in space, above Earth's atmosphere, to get a clear and unobstructed view of the cosmos. The Hubble Space Telescope is a prime example, allowing astronomers to capture breathtakingly detailed images of distant stars and galaxies without the interference of atmospheric twinkling. Interestingly, the twinkling of stars has also been used as a tool in scientific research. Astronomers can analyze variations in the light from a twinkling star to study Earth's atmosphere and even detect exoplanets. For example, when a star's light passes through a planet's atmosphere during a transit, it can cause specific patterns in the twinkling, revealing information about the planet's atmospheric composition. This method, known as transmission spectroscopy, has become a key technique in the search for potentially habitable worlds beyond our solar system. The intensity of star twinkling can vary depending on environmental conditions. On nights when the air is calm and stable, such as during a temperature inversion, stars twinkle less because there is less atmospheric turbulence. These are the nights astronomers describe as having good seeing. Conversely, on windy or turbulent nights, stars twinkle more vigorously, and the quality of astronomical observations diminishes. This is why many observatories are built at high altitudes, where the atmosphere is thinner and more stable, such as the Atacama Desert in Chile or Mauna Kea in Hawaii. For amateur stargazers, understanding why stars twinkle can enhance your appreciation of the night sky. Twinkling can add to the beauty of stargazing, making stars seem alive and vibrant. However, if you're trying to observe faint objects or capture astrophotography, it's best to choose a clear, calm night and a location far from city lights, where atmospheric conditions are more stable. In summary, stars twinkle because their light is constantly bent and scattered as it passes through Earth's turbulent atmosphere. This phenomenon, caused by atmospheric refraction, is a delightful reminder of the dynamic nature of our planet's environment and the immense distances between us and the stars. For students of astronomy, the twinkling of stars is a gateway to understanding light, atmospheric science, and even the tools and techniques astronomers use to study the universe. The next time you look up at the night sky and see stars shimmering like tiny diamonds, remember, behind their twinkle lies a fascinating blend of science and wonder that connects us to the cosmos.